Hi, today we're starting Chapter 7, Linear Systems of Equations. Lesson 7.1 is called Solving Systems of Equations. This is kind of a review of Algebra 2 where you had two separate functions, mostly linear, and had to solve for two separate variables. So our goal for today, or our objective, is that students will know how to solve systems of equations by substitution and by graphing. So we're going to look at substitution, and graphing. Your homework is going to be to copy notes from this video. So tomorrow in class, what I'm going to look for is to see that you have the title, the lesson, any problems that I've done out, that you have those in your notes, any definitions, pretty much anything I write down or say. I'm going to be looking for tomorrow. So let's get started. We're first going to start by defining a system of equations. So a system of equations this is the process of solving two or more equations at the same time. The key word here being same. One process that we're going to use is substitution. So let's go ahead and use substitution first. Another name for substitution is algebraic. So the substitution method is sometimes known as algebraically. So let's start with two equations. Let's look at x minus y equals 0 and 5x minus 3y equals 6. So our solutions to these two equations, because we have two equations and two unknown variables, we can use either a substitution method or graphing. So our solution is going to be where they intersect. So that's really important. The solution is where the two intersect. So this is either going to be seen on a graph. So if you have a graph of two lines where they intersect, or if you're solving algebraically, your final answer will be a point. It'll be x comma y, and that's going to be your solution. It's where the two functions intersect. Let's keep with that x minus y equals 0 and 5x minus 3y equals 6. Remember, you can pause at any time. And I want to see if my point 3 comma 3 is a solution. So do these two functions intersect at the point 3 comma 3? So in order to do that, because you're given the point, you can substitute it in. So let's see. This point's kind of easy because they're both the same, but remember your x is your first value and your y is your second. It's alphabetical, x comma y. So using my first equation, x is 3, y is 3. Does that equal 0? Yes. Even though it works for the first one, we have to check to make sure it works for the second one. So I have 5x, so 5 times 3, minus 3y, so I get 3 times 3, equals 6. So let's go ahead and multiply that left-hand side out. 5 times 3 is 15, minus 9. 15 minus 9 is 6. Excellent. So that's right. Because the point 3 comma 3 worked in both of my equations, it is definitely a solution. If it worked in one of the equations but not the second, then it would not be a solution. It has to work in both of them in order for the point to be a solution. Hopefully this is all coming back to you. Let's go ahead and try an example where we have to actually solve for x and y. So let's call this example 2. That last one we did was example 1. Alright, so example 2, new problem. In this one, let's do x plus y equals 5. And my next equation, x minus y equals 3. Remember, if I'm going too fast, just go ahead and pause. So we're going to use the algebraic method here, or substitution. You're going to learn a lot of different methods, and sometimes you'll have a choice of which you want to do, and other times you'll be told, so you want to make sure that you know how to do all of the different types. So for substitution, you need to get one of your variables by itself. So whether you choose equation 1 or equation 2, it doesn't matter, but you need to get one of the variables by itself. So I'm going to stick with equation 2. And I'm going to try solving for x. So I'm going to get x by itself here. So to do that, I'm going to add y to both sides. So now x equals 3 plus y, or y plus 3. So this is great. I have x by itself. Since I already used equation 2, I don't want to use that one again. I'm going to go to the unused equation. So I'm going to substitute this in to equation 1. Because I know that x is 3 plus y, I can substitute it in. So I get 3 plus y, so that's where my x was. And then I keep going. Plus y equals 5. So let's simplify that a little bit because that's kind of messy. So I have 3 plus y, so I'm going to make that 2y equals 5. So now I have just one unknown. So I'm going to solve for y. I'm going to do that by subtracting 3 from both sides. I want to get y by itself. So I have 2y equals 2. Divide both sides by 2. So y equals 1. Awesome. So I have one of my points, or one of my values for my points. So remember, it's x comma y. So I have an unknown for x, and I know that my y is 1. So let's go ahead and figure out what that x is. Now that we have the fact that y equals 1, we can substitute, there's that word again, it into either equation 1 or equation 2. Let's go ahead and do equation 2. You'll recall that equation 2 was x minus y equals 3. So we know that y is 1. So x minus 1 is 3. Go ahead and add 1 to both sides. So x equals 4. So my point, that's an awful looking 4, is 4 comma 1. This is where my two functions intersect. So let's go ahead and graph them. Graphing is our second method. So if you're not going to solve algebraically, you can solve by graphing. So let's see. I had equation 1. So still working on example 2, the same functions. So there's equation 1 and equation 2. To graph, I'm going to put them in y equals mx plus b form. You can do a couple different ways. You can do intercept form. Doesn't really matter. But let's go over y equals mx plus b while we're here. Remember, y equals mx plus b. You want it to be y equals. So I have y equals, I'm going to bring my x over, negative x plus 5. So this is a function. It's going to be linear with a slope of -1, and a y-intercept of 5. So I'm going to go up 5 units. And slope, I'm going to go down 1, over 1, down 1, over 1, down 1 over 1, down 1 over 1. Okay. So there's my first line. My second one, let's go ahead and do this one in blue. I've got a -y, so I'm actually going to move my y over. So I get y equals x plus 3. So my y-intercept is 3. So I go to 3. Nope, it's going to be a -3, right? Yes. All right, so let's go ahead and fix that. Because I'm subtracting this over. So -3. So my y-intercept's -3. My slope is 1. So from here I'm going to go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. So there they are. They're intersecting. Let's see, 1, 2, 3, 4. 4, 1. We were right. So this just proves that you're correct. So sometimes you'll be asked to graph. You'll have to remember how to graph a linear function. Other times you'll have to do it algebraically, where you get one variable by itself and then substitute that value in for it. Alright, so that finishes up example 2. We actually looked at the two different kinds, algebraically and graphically. I'm going to walk you through one more and then you'll be done. So let's look at the next. Same exact process. This next example, we've got x squared minus y equals a -6. So right away you should be thinking x squared, that's not linear, it's quadratic. And my second equation is going to be x minus 4y equals 8. So where in Algebra 2 you mainly solve systems with linear functions, here in Intro to Calc and Statistics, you're going to be using not only linear functions, but quadratic, cubic, exponential. Doesn't matter. We're going to play with them all. Alright, so let's get started. You want to get one variable by itself. So equation 2 is a simpler equation because it's linear, so let's go ahead and get that x by itself. So to do that, I'm going to add 4y to both sides. So this is the substitution method. I have x equals 4y plus 8. Now that I know what x equals, I'm going to go ahead and substitute that into equation 1. So it's x squared, so it's going to be 4y plus 8 squared minus y equals a -6. So the only thing I substituted in was my value for x, which was 4y plus 8. Now I have 4y plus 8 squared, so we're going to multiply that out. Remember, the square means it's an inside term multiplied by itself. So it's not just 4y squared, 8 squared. It's actually 4y squared. 4y plus 8 times 4y plus 8 minus y equals a -6. So let's FOIL that out. You get your first, which is 16y squared. Your first, your inners, your outers, that's 32y times 32y. Oops, sorry. All over the place. All right, plus 32y plus 32y let's see, plus 64. Equals a -6. So, like terms here, you've got 16y squared plus 64y. Let's add 6 to both sides. So plus 70 equals 0. All right, so I don't know about you, but if we want to solve for y, we have to figure out what y equals. So you can factor out the greatest factor from here, but I don't really, other than 2, can't think of a factor. So that goes into 70, 16, and 64. So let's go ahead and use the quadratic formula for this. And this is why I'm doing this one, because it's a little trickier. We can use the quadratic formula. I don't know why this 32 doesn't move. We can use the quadratic formula because it doesn't even erase. All right, let's go move that back down. Oh, there it goes. Okay. You can use the quadratic formula because this equals 0. So let's go ahead and do that. I know you remember it. It's negative b, and the 64 is your b, plus or minus the square root of b squared minus 4 ac all over 2a. All right, so there you have it. Let's go ahead and multiply some of this out. 64 squared. All right, so that's 64 plus or minus the square root of 64 squared, which ends up being 4,096, minus 4 times 64 times 70 is 4,480, all over 32. Now, just looking inside our square root, we can easily see that we're going to get a negative number. And if you think about what that means, I wish I could get rid of that 32y. If you think about what that means, a negative inside the square root just means that you don't have any real solutions. There's no solutions. There's no x value. Your quadratic is never going to cross the x-axis. You still have a quadratic function, but just has no x value. So if your quadratic function has no x value, it's not going to cross or intersect with your linear function. So for this one, the answer is actually no solution. If there's no point of intersection, it's no solution. So that's why quadratics are a little trickier to deal with. Let's go ahead and look at that graph really quickly. You could put it into your graphing calculator, and I'm just going to do a quick sketch. The graph of the quadratic, worst quadratic ever, looks like this, where it doesn't cross your x-axis. Our linear function, if you remember, we had got it to x equals 4y plus 8. But let's get that y by itself. So I'm going to move that 4y over, and move my x over. I'm going to divide everything by negative 4 to get y equals, I'm going to end up, if I divide this by negative 4, my slope's going to be a positive 1/4. And then 8 divided by negative 4 is negative 2. So I have a y-intercept of negative 2. From there, I'm going to go up 1 over 1, 2, 3, 4. Up 1 over 1, 2, 3, 4. Wow, I put that point in the wrong spot, didn't I? Alright, let's try that again. From here, up 1 over 1, 2, 3, 4. There you go. Up 1 over 4. So it's going to keep on going. So you see those two functions are never going to intersect. Therefore, there's no solution. There's no point of intersection. So you're done. Alright, let's check out your problems for homework. So normally, this is what's going to happen. You'll have notes. You'll take notes on your notes of the videos that I'm giving you. And then you'll have challenge problems. You'll have 1 or 2 problems that you have to do on your own based on the video you just watched. And you've got to bring these to class as well. Sometimes they'll be collected and graded, and other times we'll just go over them together. So, let's look. So your challenge, your homework for tonight. two problems. The first one is the point 0, 1 a solution to y equals e to the x and x plus y equals 1. So go ahead and see if the point 0, 1 is the solution to those two functions. Does 0, 1 work? Is it the intersection point of those two graphs? And then the next one is solve for that intersection point algebraically. Remember, show all of your work. And I'm just checking. That looks like I spelled it wrong. And graphically. Alright, so let's see what our two functions are. You've got x minus y equals a negative 4, and then you're going to see if that intersects your quadratic function at all. X squared minus y equals negative 2. Remember, I'm looking for work there, algebraic work, so whether that's the quadratic formula or not, and then, of course, the graph. Alright, good luck.